Okay, class is working on filling out this book that we gave, and you're going to have to come into class and get it. I can't, that's not something I can supply online to really teach you how to do this, and you can hear the class talking in the back. So this book takes 12 functions and identifies the characteristics of them. And the one thing, the first one that's the most basic is the linear or basic line identity function. Y equals x, slope of 1, y-intercept of 0. And then we fill in all these things. And hopefully all this stuff up here makes sense. Again, you're going to have to wait to get in class to get your book in order to look through this and do this. But as far as end behavior, and if you had me last year, I did not do this terminology, and I should have. For end behavior, if you remember what we did last year, we said as x approaches infinity, what does y approach? Well, as x approaches infinity, y, you can see, approaches positive infinity as well. Oh, great. That's going to come up a lot. Well, we have to change that to what's called limit notation. And really what you got to trick yourself right now instantaneously is this means the same as what this says up here. F of x is the same as y. And you can see this x approaches infinity below. So what's the limit as x approaches infinity of y? Infinity. So this is the same as that, and you need to get that taken care of. So now what I'm going to do is get the class back together, and we're going to go through what they worked on and check that they have the right answers. So pay attention, and then I'll stop if you have any questions. Squaring function, hopefully you have your domain and range correctly written there. All right, and again, you're just going to have to look at the video and make your corrections. I think I did this 2 years ago when we were still, at an impasse. Do we use brackets or parentheses for increasing, decreasing? Books switch back and forth. When I introduced the book, this year, they use brackets. So, I don't know, it's arbitrary what's right or wrong on that, but hopefully you get that figured out. The squaring function is that picture. There are local extrema. There's a minimum, and that's what I want you to write. Min. You don't have to put local just because of space. That means it is bounded below. Then real quick again on the limit behavior or end behavior. As x approaches infinity, what does y approach? What's the answer to that? Infinity. And then the negative one. I should cut and paste this so I don't have to keep writing this. As we approach negative infinity for x, what does y approach? Infinity as well. So the y's infinitely go up as you go negative for x, the y's go up. Okay, so that's the x squared function. And again, you discussing, talking, I think just about everybody got this right, and I love it. What's the next one? Cube. Okay, it may take me a while to find that one. I think about the wrong way. You're going the wrong way. Okay, cubing function. Hopefully you got that picture. Again, I gave you a blank graph. You had to come up with some points. 0 cubed, 1 cubed, 2 cubed. Same thing with negative 1. That's you just make points. That's how you make pictures. All right. I don't think I have to. That's going to keep coming up. I don't know why. I'll have to hit something on that. There is only increasing behavior on that, and this is a classic odd function. And everything else is irrelevant. Okay, there is no boundedness, no extrema, blah, 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 blah. Limit, as x approaches infinity, what does y approach, everybody? Infinity. How about negative infinity? It's negative infinity, negative infinity. So I'm just going to write one of these. The limit as x approaches infinity is infinity. So that's how you're going to write end behavior from now on. What's the next one because of time? What's the next one? Square root function. Did I pass that before? Let's see. Square root, ln. Oh, boy. There we go. Now, I had to get on some of you guys. How do I get the square root function? Can I plug in negatives? Yes or no? No. Can I plug in 0? What is the square root of 0? What's the square root of 1? 1 comma 1. What's the square root of 4? 2. What's the square root of 9? 3. So this is the picture. That's what graphs are. And of course, I can plug in decimals and take square root of decimals. All right, so that's the picture we should have got. Couple questions. It is bounded below. I don't think that's called a minimum, though. I think in a classic curvature sense, when your graph curves and then comes back up, then we can call that a minimum. I will ask a higher level calculus teacher Their idea, but it is bounded below because there is a smallest y value. It actually is continuous because when I start at 0, 0, and then I draw it, I never have to pick up my pen or pencil. So it is considered continuous. Then the end behavior, there is only one that we care about because I can't even plug in negative y's for this. And then believe it or not, what's the square root of infinity? That's the question. What's the answer? Infinity. So the y's do actually infinitely go up, even though they go up pretty slow after a while. Okay? All right. Oh, boy. Oh, boy. There we go. Oh, here's absolute value. I'm just going to say limit as x approaches infinity and the limit as x approaches negative infinity are both infinity. You can see that. Even, continuous, blah, 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 blah. Should change these to parentheses. That's just a notational thing when we talk about increasing and decreasing. Okay, and then walking around looking at your worksheet, which, you know, you need to write your asymptotes as dotted lines. So I don't know if I did that real great here. I'm actually showing some odd behavior there, though. These 2 points are symmetric about the origin. I'm done. Okay? But really what you should do for this graph is draw the asymptote specifically. So there is a vertical asymptote at x equals 0 because that's how you find vertical asymptotes. 0 is the denominator. And the numerator's degree is smaller than the denominator's. So there's a horizontal asymptote at y equals 0. All right, and what that affects is both the domain and range. That's what we need to understand about that. And there is a discontinuity. It's an infinite discontinuity at, I should have put, x equals 0, and that's how you should write that. It actually is increasing and decreasing. How do I just... Don't show this message. If that comes back, I'm going to be infinitely angry. Speaking about infinity. Anyway, I digress. These are both decreasing, but they're two different intervals because there's two different chunks. So I do have to say that there's two different decreasing intervals. Then the end behavior. This is awesome. What's the limit as x approaches infinity? What does y approach? Not infinity. It's what? That's the whole point of the asymptote. As you get awfully large for x, y actually approaches 0. And then what about, what's the matter over there? All right. And then what about x approaches negative infinity? It's also 0. So good job. How many people got that? Raise your hand if you got to that one and actually said that. That really, okay. Here's the whole explanation, and you need to go fast on this or watch the video at like 7 minutes and some seconds. That's where I'm at right now because we don't have a lot of time for this. Remember E. People in my Algebra 2 class, I did do E a lot. E is like pi as far as an important number for certain things. So I'm done with that. We're going to have a whole chapter 3 on E. E is approximately 2.718. So in order to think about E, 2.718, I compared it to just 2 because it's awfully close. What's 2 to the 0? What's anything to the 0 power? 2 to the 0 is what? Help me. 2 to the first is what? 2 to the second is what? 4. So that starts taking off. What about negatives? What's 2 to the negative first? What's 2 to the negative first? 1/2. What's 2 to the negative second? 1/4. 2 to the negative third, 2 to the negative 100th. So I just did 2 instead of 2.718 because it's close enough. It's a good little, 2 to what power, what happens with the y values. Lo and behold, what do you have here? You have a what? You have an asymptote. That graph is never going to get to 0. All right? You can't take 2 to a power and get 0 out of it. All right? So these are the things that are true about it, and then I'm just going to verbalize the limits. What's the limit as x approaches infinity? Where does y go as I plug in big numbers for x? It goes to infinity, but this is what's strange. What happens when x approaches negative infinity? You get close to 0 but never get there. That's the idea of limit. The word limit really works here. What's the limit of y as x approaches negative infinity? The idea of limit is approaching, not getting there. So that's why that term is used. Now, I did leave the graph because it's unfair to ask you this as Algebra 2 honor students, I as a teacher should have taught you at least a sine and cosine graph, what it looks like on a coordinate plane. You'll get it this year and you'll understand it. It's really not that bad. So really what it is a wave. You know, it's a wave like this that infinitely goes up and down like this. You know, the range is only from -1 to 1. It only gets as high as 1 and as low as -1 on this picture. And it does this forever. All right, so I'm sure you've seen a wave, like a sound wave on a, you know, like something more AM/FM modulation, listening to the radio. You know, those are sound waves. So anyway, the increasing, decreasing behavior, you're going to faint. Look at the yellow. Those are what? Yellow are what? And then look at the green. Those are what? And this happens forever. So the only way we could do this is to learn more how to write that notation. So that's going to be put on hold. This book does this. This assumes that you've learned a lot of stuff that not necessarily we did do last year. It is definitely bounded below and above. So it's just called bounded when that happens. And it is odd. You know why? You ready? There's odd symmetry. That's the only way you can do that, by looking at that picture and seeing that there's odd reflections here. No asymptotes and behavior is nearly impossible to answer because it continually oscillates between 1 and -1 for y forever. So what happens with cosine? Something very similar. And then the only thing I forgot was, and then we have greatest integer, which I was mean about. Where's cosine? There it is. Cosine's a little different, and we only have 3 minutes. So again, you may have to look at the video to take this stuff down. So cosine looks almost exactly like sine, except it's shifted a little bit. And actually, when you look at this, look at the y-axis. What kind of symmetry does it look like sine has that's a little different than cosine? It's even. It has y-axis symmetry. Actually, cosine is just a shifted sine. But we do want to make those distinctions, so on and so forth. So tough to answer now. Local extrema. How many extrema are there? Starts with an I and ends with infinite. Okay, there's a whole bunch of maximums and a whole bunch of minimums forever and ever and ever. So that's why that's kind of tough to answer now, and I don't even know how to answer end behavior because the y's oscillate between positive and -1 forever. Okay, so that's kind of tough for that. And then the last one, and then the only thing I'm going to leave you hung out to dry is the greatest integer. So I may just show you that. And then maybe you can look at the video for that if you want more explanation. I'll show you it if I can find it. There's a logistic. Remember, that's in the middle. I think greatest integer is up at the top. Okay, what's silly about greatest integer? Did I give you this picture? All right, I wanted you to discuss and combine, and have some, your own stuff, and then we just ran out of time for filling this out here. I'll talk about this maybe more tomorrow offline. If you want to look at this and just fill it in and copy it, fine. Look at where are we at in the video, 1335. And then you can copy that down. And then the same thing for the logistic function. I'm not going to do a lot with the logistic function. I don't really think it's one of the 12 basic functions. I could tell you more about it, why it exists, but so on and so forth. Do look at your assignment. The assignment is actually not that bad. You basically have to look at your book and then just answer questions based off of that.